Hi everyone, hope you all are good. So we are here for grade 9 math. So we are working on the chapter powers and polynomials. The lessons we're going to cover today are power of a power, adding and subtracting polynomials, and multiplying a polynomial by a monomial. So let's just start with the lesson. So we'll be working on the book, that is Principles of Mathematics grade 9, working on chapter 2 powers and polynomials. So let's just start with the first lesson, that is okay. Let's just lesson, that is power of a power. Okay, let's just start with the practice questions. Okay, here I'm on practice questions. So let's just start with practice questions. Question number 3, it is express each of the following as a power with a single exponents. So they are written with the double exponents like 3.4 times 2. So you have to write them down as a single exponent. Got it? Let's just start with the first one, 3 exponent 4, and for the whole the exponent is 2. Question number 3, 8 is 3 exponent 4, and then here you have to. Okay, so basically here you have to apply the power of a power principle. That is, if you have something written like this, a times m and the exponent n, you can write them as a m exponent n, like you have to multiply both. That is the power of a power principle. You have to apply it here. That would be 3 4 times 2, so you can write it as 3 exponent 8. Got it? Let's just do another one. That would be 5 squared exponent 4. So you have to apply the power of a power rule. That would be, you have to do 5 times 2 exponent 4. So it would be 5 times 8. So you can write it as 5 times 8 it is. Got it? Okay, the next one is, just look at the question number 4. Express each of the following. Express each of the following as a power with the base indicated. A is 16 square with a base of 4. Basically, you have to write 16 square as a base of 4. Question number 4, A it is. You have to write 16 square as a base of 4. Got it? So how do you write as a 16 square as base of 4? You can write 16 as 4 times 4. Got it? Just simply look at the 16. You can write 16 as 4 times 4 or either 4 square. So you can write it as 4 square and this one is square. You can write 16 as 4 square and then you have square. You have to write down the um, exponent as a single one. So you can write 4, 2 times 2. So it would be 4 exponent 4. Got it? You can write it as 4 exponent 4. Okay. The next one is, okay, 27 exponent 3 with a base of 3. Okay, the next one is 27 exponent 3. So you can write 27 as 3 times 3 times 3. Got it? So just write 27 as 3 exponent 3 cube and just apply power of a power rule here. it would be then 3 exponent 9. Got it? So 27 exponent 3 and 3 exponent 9, they both are exactly equivalent. Got it? Okay. Just look at the question number 5. Explain each principle and give a numerical example. Okay, so you're given with they are actually the principles we're applying here on the power questions related to the power. So you have to explain. The first one is AM and N. That is the power of a power rule. I just explained. Got it? Question number 5, 8 is, let me just write it down and then I'll explain. Okay. AM times N equals AMN. Got it? That is part of a power rule. Got it? You have to, whenever you have written something written like this, you have to multiply. For example, a time, sorry, we have done 2 times 2 and exponent 4. We have already done with some examples like this. So you have to do 2 exponent 2 times 4. So it would be 2 exponent 8. Got it? You have to multiply the exponents. Okay, the next one is a m b n and exponent p. Then you have to multiply p with a am a n. The whole has the exponent p b n. Sorry, you can write them as amp and bnp. Basically, you have to. This p is the exponent for both am and an. Got it? So you have to multiply the power p with both m and n. Got it? Okay, let's just move on to next one. Okay, let's just start with question number 6. You have to simplify 3 exponent 4 square and 3 exponent 5. Okay, that is 3 exponent 4 square and 3 exponent 5. Okay, first we have to apply on this one. We have to apply power of power principle. Got it? You have to do 3 exponent 4 times 2 and write 3 exponent 5 as it is. So it would be 3 4 times 2 exponent 8. Got it? Now you can see both the bases are same. Got it? So you have to apply the exponent principle of product whenever you have to you are multiplying the same base, same you have same bases, they are multiplying, their powers will be added. So it would be 8 plus 5 equals 13. That would be 3 exponent 13. Got it? Okay. Okay, let's just start with the next one, question number 7. The first one is simplify y cube exponent 4. You have to apply power of a power rule here. It would be y exponent 3 times 4. Got it? So it would be y exponent 12. Okay, let's just look at the question number 8. Simplify v square square v. Okay, you can do 8 yourself. That is exactly easy. Let's just look at question number 9a. So you can do 3a square and cube. You have to apply power of power rule here. The 3 is the exponent for everything that is inside the bracket, like 3 is the exponent of 3 and 3 is the exponent of a square also. Got it? So here you have to apply the power of the power rule. It would be a 2 times 3. So when you evaluate it as 3 exponent 3 and a 6. Also you can evaluate 3 exponent 3, that would be 3 times 3 times 3. So it would be 27 a exponent 6. Got it? Okay, let's just look at question number 10. Let's just start with the first example. Okay, question number 10a. It is 4 cube times 3 square and whole square. Then you have 4, 5 times 3 square and whole cube. You have to evaluate. Got it? First, just apply power of a power principle. Got it? The 2 is the exponent for both the values. Got it? So it will be 4, 3 times 2 times 3, 2 times 2. Same thing you have to do here. 4, 5 exponent 3 times 3 exponent 2 exponent 3. Got it? So it would be 4 exponent 6, 3 exponent 4. Same here, 4 exponent 15 and 3 exponent 6. These are the same bases and they are multiplying. You can add their exponent. It would be 4 exponent 6 plus 15. Same thing you have to do with this one. Bases are same. You can add the power. So it would be 4 exponent 21 times 3 exponent 10. Got it? Okay, just look at the question number 15. So many examples. Okay, so question number 15 is you have to evaluate 2 cube exponent 4. Okay, question number 15a. To be 2 exponent 3 and 4 divided by 2 exponent 2 and 5. So you have to apply the power of power rule first. That is 2, 3 times 4, 2, 2 times 5. That would be 2 exponent 12 divided by 2 exponent 10. You can see for both the numerator and denominator, the bases are same. So that means that here you have to apply exponent principle of quotient. Got it? You have to 2, 12 subtract 10. Got it? So 10 subtract 10 is 2. So you are left with 2 exponent 2 and 2 exponent 2 equals 4. So the answer for this one is 4. Got it? So it would be 4. Okay. Let's just move on to question number 17. Show that okay, show that 3 exponent 10 is same as 9 exponent 5 using your understanding of exponent. Okay, so we have to prove that 3 exponent 10 and 9 exponent 5 are equivalent. Got it? Question number 17 it is. You have to evaluate 3 exponent 10 and 9 exponent 5. They are equivalent. Got it? How can we evaluate? We can write 3 exponent 10 as 3 exponent 2 times 5. Got it? Then you can write them as 3 exponent 2 times 5. You are applying power of a power rule here. And we know that 9 square, 3 square is 9. So you can write 9 exponent 5. See, they are equivalent. Isn't it? Got it? They are equivalent. Okay. Just look at question number 22. Describe the relationship between the power of a power principle and the other exponent principles you know. So basically we have to see if the other principle with power of a power exponent have a relationship. Got it? So when we apply power of a power component exponent, we multiply the exponents of the power inside the parenthesis by the exponents outside the parenthesis. Got it? So when adding exponent principles of product, we add the exponents of the powers with the same base. Got it? So applying exponent principle for a product, we subtract the exponents of the numerator by the denominator with the basis. Got it? Okay, you can complete the rest of the questions by yourself later today. For the lesson, rest of the lessons by yourself later today. Let me just move on to the next lesson. So here you have a mid-chapter review. You on your own do as many practice questions, and if you need more help with the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. Got it? Okay, the next lesson is adding and subtracting polynomials. So we're going to learn how to subtract the polynomials. This is well, let's just start with the practicing. Okay, let's just start with question number 6. Draw an algebra tile representation for each polynomial. So we have to represent using algebra tiles how do we add them. Got it? You have x squared plus 3x. So you can represent x squared plus 3x as you have to make a tile that represents x squared, and for 3x you have to make 3x tiles. That's how you represent x squared plus 3x. Got it? Okay. Okay, let's just start with question number 9. You can do the tiles we're on with by yourself. Let's just start with question number 9. So question number 9 is simplify the following. So basically you have to add, you have to collect the like terms. Got it? So let's just start with the first one, question number 9a. It is 3h plus 1 plus 2h plus 5. Basically, you have to collect the like terms here. Got it? So what do the like terms mean? The terms that have the same variable or either no variable, they are constant, they are the like terms. You can collect them. Collect means you can add or subtract them, whatever operations. So you can see here 2h and 3h are the like terms because they have the same variable. So you can add them because the operation is adding here. Then 5 and 1, they both are constant. You can collect them. So it would be 5h plus 6. Got it? Okay, let's just look at question number 10. Simplify the following. 2x plus 3y. So 2x minus 3y and plus 3x plus y. 2x minus 3y and 3x plus y plus 3x plus y. So first of all, remove the parenthesis with 2x minus 3y plus 3x plus y. You can now collect the like terms. 2x plus 3x is 5x, minus 3 and plus 1 is negative 2y, so it is 5x minus 2y. Got it? The next one is question number 11. Simplify 5x minus 4y Let me just write it down on the board. 5x minus 4y and minus, so basically we are subtracting polynomials now. So when subtracting polynomials, you have to change the sign of the polynomials that are right after the negative sign, because negative sign changes all the signs. When you remove both the brackets, it would be negative 3x and negative 2y. Because of this negative sign, both the signs got opposite. If they are positive, they are then negative, and if they are negative, they are then positive. So you can now collect the like terms. 5 minus 3 is 2x, minus 2 and minus 4 is minus 6y. Let's just do another example from the same question. It would be question number 11c. Okay, 11c is 3x square minus 4xy. Okay, let me just write it down on board. 3x square minus 4xy plus 6y square, and the other one is minus 6 minus 8 minus 3y square. Okay, minus 6x square minus 8xy minus 3y square. Okay, you can see you're subtracting polynomials. Got it? So subtracting polynomial, this negative sign change all the sign that are inside the bracket. So it will be 3x square minus 4xy plus 6y square. It will be negative 6x square. This will change to positive 8xy, and this will do positive 3y square. Now you can collect the like terms. 3x square and negative 6x square is negative 3x square. Negative 4 and positive 8 is 8 minus 4 is 4. It would be 4xy, and 6 plus 3 is 9y square. Got it? Okay. Okay, let's just look at the question number 15. Okay, Jan is a plumber. She charges $35 to visit a job site. Her hourly rate is $43.50. Fred repairs furnaces. He charges $41 for a service call plus 38.75 per hour. Let X represents the number of hours they work. You have to A represent Jan's bill as a polynomial. Okay, so Jan is working, she charges $35 to visit a job site, and her hourly rate is 43.50. You have to write down as polynomial. So it would be the fixed amount is 35, and hourly she charge 43.50x. Got it? X is the hours. Okay, then B is represent Fred's bill. Okay, 41 is the fixed charges, and then 38.75 for hours. Got it? Okay, the next one is write an polynomial that represents Jan's and Fred's combined charge. Oh, so you have to add both one. Got it? For C, you have to add. It is 35 plus 41 is 76, and you have to add this also. It would be 5, 2, 2, and 8, 82.5x. When you add them, it would be 76 plus 82.25x. Okay, for decalculate the combined charge if they both work for 8 hours at the same complex. Okay, now you are given for D part, you are given x is 8 because we represented hours by x. Got it? So just if they combine work for 8 hours, you have to calculate the money. So just replace the x by 8 and do the calculations. So let me just do 82.25 times 8, 658 and plus 76. That means if they combined work for 8 hours, they will get charged. The charges they have is $734. Got it? Okay, you can complete the rest of the questions. On the next page, we also have so many problems. Okay, let's just do question number, another word problem we can do. Let's just do question number 17. I thought we are just done. Okay, let's just do another one, question number 17. Okay, in a TV game show, each player begins with, what is this? Okay, in a TV game show, each player begins with 1,000. For each question answered correctly, a player received $125. For each one answered incorrectly, a player must pay $250. Express the total winnings for a player using an algebraic expression. Use the expression from part A to find the total winnings for the three players. If player 1 answered 12 questions, player 2 answered 10 questions correctly and 2 incorrectly, and player 3. Okay, let's just start with question number 17a. First, we have to write down the 1,000 is fixed. Got it? And then he receives 125 for each correct answer and deduct 250 for each wrong answer. Got it? So that is question number 17. Okay, 1,000 is the fixed one. Let's just C is the variable that represents the correct questions. So for the correct question, he received 125 C. And for incorrect, the deduction is 250. So you have to subtract, not add, because he have to pay. Got it? I is for the incorrect question. Okay. Now you have to evaluate if player 1 answered 12 questions correctly and 8 incorrectly. Okay, 12 questions correctly and 8 incorrectly. So replace C by 12 and I by 8. Got it? Just evaluate and see the answer. Where is the calculator? Okay, so you have to do 125 times 12, that is, sorry, 125 times 12, that is 1500. 1,000 plus 1500 and 250 times 8, that would be, I think, 2,000. Yes, that is 2,000. So just add 1,000 plus 15 is 1,500 is 3,500. 2,500 and 25 minus 2,000 is 500. That means player 1 have 500. You can calculate the same way the rest of the values. Got it? Okay, let's just start with the, you can do the rest of the practice questions by yourself later today. Let me just move on to next lesson. Multiplying a polynomial by a monomial, 2.5 it is. Okay, let's just start with the practice questions. So we are going to multiply a polynomial by a monomial. Monomial is something that is, polynomial means when you more than one terms. Monomial means only one term. Got it? So let's just start with the practice questions. The first one is x and 2x plus 1. So here x times x is the monomial. Question number 4. X is the monomial. Mono means alone. That is the polynomial. Got it? How do you multiply? You have to multiply the number that is outside the bracket with first expression, first term, then you have to multiply with the second. You have to do x times 2x and x times 1. So it would be 2 times 1 is 2x and plus x. It would be 2x plus x. Got it? Okay. Let's just look at the question number 6. You have to expand. Okay, let's just start with question number 6. You have to expand. Expand means 2 times negative y square, negative y, negative 1. You have to do 2 times negative y square. So you can write negative 2 times y square. Then you have to do 2 times negative y. It would be negative 2y. Then you have to do 2 times negative 1. It would be negative 2. This would be the expanded form of this one. Got it? Okay. Let's just question number 7. Determine the missing factor. Okay, you have to find the missing factor. You can see here you have 2x, here you have 6x, minus 10, and here you have minus 30. You have to find a number that when multiplied by 2x makes 6. So what number it is? 2 times what number is 6? 2 times 3 is 6. That means the missing number is 3. And also 3 times 10 is 30. So yes, the missing number for question 7a is 3. Got it? And for b it is 2 because you can see here you have just x cube and here you have 2x5. Got it? Here you have x cube, so that means the one you have to multiply is 2x square. Got it? Because here you have x exponent 5. Got it? Okay, the question number 8 is evaluate each statement for p equals 5. So you just have to replace p with 5 in question number 8, and then you have to calculate the value. Like a part is 3 times 4 times 3p plus 2, and you have to evaluate for p equals, hold on, p equals 5. Just replace p with 5. It would be 4. 3 times 5 plus 2. 4, 3 times 5 is 15. You have to evaluate the bracket first. 15 plus 2 is 17. So 17 times 4 is 68. Got it? Okay. Let's just start with question number 10. You could evaluate 20 times 47 by doing your calculations. 20 times 40 plus 20 times 7. How is it like using the distributive property to solve x times 2x plus 7? Okay, basically that is a distributive property you applied. Got it? You can do the same way x times 2x plus 7. You have to do x times 2x and x times 7. That is exactly the distributive property you are going to apply. Got it? It would be 2x squared and plus 7x. Got it? Okay. Let's just look at question number 13. These polynomials are expanded using the distributive principle. We state them as a product of two factors. Okay, so they are expanded using distributive property. You have to write them down, write them, restate them back. 12x square minus 6x. So see here you have 6 is common. Also x is common. So you can write it as 6 times 2 is 12. You are left with, you already have x outside. So you're left with x. And minus 6x is outside. You are left with 1. That's how you restate them back. Got it? The b is 21y cube plus 7y square minus 14y. Okay, you can see all the numbers 14, 7 and 21 are the factors of 7. That means you have So you can write 7 as a common factor, and also you can take the smallest power common, like y is the smallest power. Here you have 3y, here you have 2y. You can take the smallest power common. So you're left with 7 times 3 is 21. 1 y is outside, you're left with square y square here. 7 is outside, you're left with 1y. And 7 minus 2 is 14, y is outside. That's how you write it. Got it? Okay. Just look at the C part. 5x square minus 10xy plus 30x. 5x square minus 10xy plus 30x. Okay, you can see all the numbers. You can see all the numbers 5 and 30 are the factors of 5. You can take 5 common. Also, you can take the smallest power common. Here you have x square, here you have x, here you have x. You can take x common. So you're left with 5 is outside, 5 times 1 is 5, x is outside, you are left with just x here, minus 5 times 2 is 10, x is outside the bracket, you are left with y, and 5 times 6 is 30, it would be just 6. Got it? Okay, we are done with the lesson also. So we were working on grade 9 maths, and we're working on the chapter powers and polynomials. So we are done with the lessons powers of a power, adding and subtracting polynomials, and then multiplying a polynomial by a polynomial. We're done with lesson 2.3, 2.4, and 2.5. Got it? So please make sure before the next session you have to do most of the practice questions for the lessons we did today. So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. That's all for today. See you in the next session. Bye everyone.